Okay, let's start. So welcome to our second webinar session of 2025. This is the new ISO 22002 Part 100 series and food manufacturing sector. Guests, cameras and microphones are muted today to save bandwidth. The scheduled duration of this webinar session is 35 minutes. It will include 2 presentations. We won't have a dedicated Q&A session today, but please feel free to send your questions via chat or email. We will answer your questions after the session. The email address is info@ledtaylor.fi. We will also record the presentations and they will be made available for later viewing. Here's today's agenda and speakers. My name is Virpi Sorri. I work as a customer experience manager at Spectral Blue by Taylor. I will be moderating this webinar today. The first presentation is relevant changes in new ISO 22002 Part 100 series for food safety and microbiological quality and how blue light helps in achieving compliance. The presenter is our sales manager, Bob Meyer. And the second presentation is a research review, the latest results on foodborne pathogens and automatic blue light disinfection. And the presenter is Dr. Kirsi Saukkonen, our senior scientist. And after this, we will be closing the session. So let's start with the first presentation and Bob Meyer.
Yes, hello. Good morning, everybody. So today I will talk about the new ISO 22002 TS100 standard and food manufacturing. And like Virpi said, my name is Bob Meyer and I'm the sales manager at Taylor. But before we start, I would like to start today's session with an anecdote. Because this photo was taken about 7 years ago when I was working as a QA manager in a food company in the Netherlands. The photographer chose blue light for the background because it looked technical and clean, which felt fitting at the time. I argued why an organoleptic laboratory would have blue light, because the picture didn't look very realistic to me. Later, in my professional journey, this blue light became a way more literal part. And for good reason. Like many of you, my focus back then was on compliance, hygiene audits, and making sure our processes met the highest standards. Today, I will introduce antimicrobial blue light as a hygiene tool that supports ISO 22002 Part 1 requirements, especially in areas where traditional cleaning and methods face limitations. We'll look at how this technology fits into prerequisite programs and strengthens contamination control strategies in food manufacturing environments. Today's agenda. First, we will delve a little bit deeper into why hygiene control matters. And then we will go to what's new in the ISO 22002 series, but with a focus on understanding hygiene control requirements to prevent microbiological contamination. Then we will discuss Spectral Blue multi-wavelength high intensity in brief, before we go to how antimicrobial blue light enhances compliance. And then to wrap it up, we have some key takeaways. So why hygiene control matters? Recalls in the EU and UK are rising and have been rising for quite a few years already now. And listeriosis hit highest records even, with the EU tightened listeria rules for ready-to-eat foods that are going to be effective the 1st of July 2026. And food safety authorities across Europe expect a culture and not just compliance. And what many of those articles about recalls have in common is that there is a clear need for stronger hazard control, with an enhanced cleaning and disinfection protocols, stricter gowning procedures with microbiological rationales. Cleaning procedures must be designed for effectiveness against specific pathogens, such as Listeria or Salmonella. and there needs to be a greater emphasis on cleaning dead spaces and hard-to-reach areas where microbial biofilms might form. But why does this matter? Because biofilm risk and cleaning inefficiencies were previously under-addressed, but now with the new ISO series, they are explicitly accounted for. One example I would like to highlight here is the food safety culture, and it's a guidance note by the Food Safety Authority of Ireland in this case, actually, that states that management commitment shall include encouraging continual improvement of the food safety management system of the business where appropriate, considering developments in science, technology, and best practices. It is time for food safety leaders to embrace a layered defense strategy, one that blends traditional sanitization with next generation disinfection, such like Spectral Blue. And in doing so, we can significantly reduce the risk posed by the likes of Listeria and multi-species biofilms, drive compliance with evolving regulatory mandates, and safeguard public health. So what is new in the new ISO 22002 series? So first, the IAF and ISO have not yet released the transition requirements and timeline for the updated standards, but the publication of FSSC version 7 is expected at the end of Q1, early Q2 2026. Certified companies will then have a transition period of 1 year. But in the meantime, companies will comply with FSSC version 6. Organizations utilizing this series of standards need to adhere to the requirements of ISO 22002 TS Standard 100 and all the relevant sector-specific parts as shown in this list. In the ISO 22002 TS Standard 100 is a focus on unified prerequisite programs across food, feed, and packing sectors. The purpose is consolidating common hygiene and safety practices from the previous sector-specific standards, such as the Part 1, Part 2, Part 3, etc. Some of the key benefits are that it simplifies compliance for multi-sector organizations, and it enhances audit efficiency and traceability. It also introduces modern risk management elements like food fraud, food defense, and sustainability. Now looking deeper into ISO 22002 Standard 1 from 2025 and the key hygiene requirements for food manufacturing specifically. Some of the topics we will focus on today are the design of facilities and workspaces, contamination prevention management, cleaning and disinfection, and then personal hygiene and facilities. The ISO 22002 Technical Standard 1 has a focus on food manufacturing with the purpose of updating the sector-specific prerequisite programs for food production environments. Some of the key changes here are a stronger emphasis on environmental monitoring, new allergen control and chemical contamination sections, a revised pest control and hygiene requirements for personnel. There's a greater alignment with ISO 22000 and modern FSMS principles. We're delving deeper into the first section, section 5. Design of facilities and workspaces. Facilities must be planned and maintained to minimize contamination and cross-contamination. They need to support hygienic operations and enable a logical flow of materials, personnel, and waste. Physical or temporal separation between raw and processed areas is essential. Walls, barriers, or distance help prevent cross-contamination. Surfaces, fixtures, and fittings, such as floors, ceilings, doors, and windows, must be cleanable, durable, and suited to the cleaning intensity required. Ceilings and overhead structures should minimize dirt buildup and particle shedding. Floors and drains must prevent stagnant water and pest entry. Equipment should be positioned to allow easy access for cleaning, operation, and hygiene monitoring. And storage areas must protect materials from dust, condensation, pests, and other hazards. Segregation of raw, intermediate, and finished goods is required. Hazardous substances must be stored securely. Then looking into section 12, microbial control and microbiological contamination prevention. Organizations must apply contamination control measures in line with the ISO 22002 TS100 requirements. Areas with potential for airborne or contact-based microbial contamination must be identified and managed through effective zoning strategies. You need to separate raw and ready-to-eat areas to prevent cross-contamination. There needs to be physical barriers, such as walls, partitions, or separate rooms even, to isolate high-risk zones. There is a need to implement access controls, requiring personnel to change into designated hygiene clothing. There needs to be a designed traffic flow to separate people, materials, and tools. Dedicated equipment may be required in this case. And there needs to be a control of the air movement using pressure differentials to prevent airborne contamination. And as you might be familiar with most of those cases, of course, there's now a stronger emphasis on the prevention of contamination and cross-contamination in all those cases. Then section 13, cleaning and disinfection. Organizations must uphold cleanliness levels that prevent product contamination. Documented cleaning and disinfection programs should cover facilities equipment, including transport containers and the work environment. Only approved purpose-fit cleaning products and tools should be used. These must be clearly labeled, stored properly, and maintained to avoid introducing contamination. Cleaning and disinfection plans must define what needs cleaning, how often it's done, who is responsible, the method that is used, and how effectiveness is monitored and verified. Programs must match the contamination risk of the products, and they need to be proven effective and executed without compromising food safety. So here as well, a lot of familiar points, but with a stronger emphasis than before on the proven efficacy, and that the cleaning and disinfection program must match the actual contamination risk. Then personal hygiene and facilities, section 14. Of course, there must be clear rules for personnel cleanliness and behavior, and they also need to be documented, communicated, and followed by all personnel, including the visitors. Hand washing stations, toilets, and changing areas must be sufficient, well placed, and hygienically maintained. Staff food must be stored and consumed in designated areas to avoid cross-contamination. And protective clothing must be clean, fit for purpose, and properly used. Hair restraints, gloves, and footwear must prevent contamination. Illnesses must be reported. Personnel must wash hands before handling products and after potential contamination. Smoking, eating, personal items, and risky behaviors are restricted. And visitors must follow hygiene protocols and wear protective gear as well, of course. Then spectral blue multi-wavelength high intensity antimicrobial blue light solutions. Spectral blue is continuous, touch-free, UV-free, and chemical-free disinfection method. It's automated and scalable, and it disinfects up to a whole room and keeps microbe levels down 24/7. It is completely safe and sustainable. It is non-toxic. It's safe for operators, equipment, and the environment. There is a proven efficacy. It eliminates all bacteria, yeast, and molds including biofilms. It has an alternate mechanism of action, so it enhances your existing disinfection practices. It's also maintenance-free. It utilizes long shelf life LED technology that requires no tube changes. And it's patented. Spectral Blue multi-wavelength high-intensity technology is protected in the EU, US, and China. And the biggest added value I would like to stipulate here is that if you look at the diagram on the left, a manual disinfection done 1 per day or every second day or whenever periodically, only momentarily brings the microbe levels down. As soon as the area is taken into use, microbe levels will grow rapidly again. And then in the meantime, while those microbe levels grow, a contamination and a cross-contamination, of course, can occur more easily. Whereas with Spectral Blue, on the right side diagram, it is automated and continuous disinfection, and the antimicrobial blue light switches on whenever the room is unoccupied, or it stays on where it does not disrupt personnel or processes. Microbe levels are brought down and kept down continuously. So how do we tie this solution into what was presented before? If you go back to section 5, facility design and hygiene zoning, antimicrobial blue light disinfection reinforces physical and temporal separation between raw and processed areas, especially where structural barriers are limited. Continuous automated antimicrobial action in high-risk zones such as airlocks, packaging areas, gowning rooms, minimize microbial transfer via the air, surfaces, and the personnel movement. Therefore, it's ideal for clean rooms, ready-to-eat zones, and equipment-intensive areas where routine chemical cleaning is impractical or disruptive. Antimicrobial blue light complements hygienic design by targeting hard-to-clean surfaces prone to form biofilms. Then looking back at section 12, microbial contamination prevention measures. Spectral Blue antimicrobial blue light disinfection reinforces microbial barriers between raw and ready-to-eat zones, especially where physical separation is limited or airflow poses risks. In areas with high personnel or material movements, blue light helps neutralize airborne pathogens, supporting zoning strategies like air pressure differentials. By continuously disinfecting shared surfaces and equipment, blue light minimizes microbial transfer across traffic routes and tool usage zones. It is ideal for supplementing physical barriers such as walls or partitions with active microbial reduction, especially in open plan or retrofitted facilities. Then section 13 again, cleaning and disinfection. Antimicrobial blue light provides ongoing disinfection between scheduled cleaning cycles, especially valuable in high-touch or hard-to-reach areas. It helps maintain required hygiene levels in production zones and working environments without disrupting the operations. It reduces reliance on frequent chemical disinfection and supporting sustainability goals and minimizing residue risks in sensitive environments. Antimicrobial blue lights acts as a preventative layer alongside documented cleaning schedules, reinforcing food safety without replacing validated procedures. Spectral Blue demonstrates proactive hygiene control aligned with ISO standards, especially in zones where manual cleaning is challenging or infrequent. How can antimicrobial blue light enhance compliance regarding personal hygiene and facilities? Spectral Blue enhances cleanliness in changing rooms, toilets, and locker areas, critical touch points for personal hygiene compliance. Continuous disinfection in staff canteens, restrooms, and corridors help prevent cross-contamination from personal items, clothing, and behaviors. It demonstrates proactive investment in hygiene infrastructure and reinforcing behavioral expectations and supporting food safety culture. It helps maintain hygiene standards in transitional areas accessed by external personnel, reducing contamination risks from outside sources. And then to wrap it up, the key takeaways. Perform your gap analysis now and be critical. Establish hard to disinfect areas, which could promote antimicrobial growth. And contact me. Let's find out how Spectral Blue can further enhance your disinfection practices. Thank you for your attention. I will now pass the stage to Dr. Kirsi Saukkonen, our senior scientist.
So thank you, Bob, and for the nice presentation. And my name is Kirsi Saukkonen, and as Bob mentioned, so I'm working as a senior scientist at Taylor Company, and my background is from mainly from healthcare hygiene and especially hygiene of the surfaces. And today I'm going to go through a couple of interesting articles dealing with food production, and let's start first with some statistics. So many questions come that do we have any scientific articles or proof about antimicrobial blue light? And the answer is yes. And here you can see the increase of the articles published from 2010 to September 2025. And this year until end of September, so we have 201 new publications, and total publications is almost 3,000, I would estimate, by the end of this year. And then the things that help you dealing with these articles is, of course, you have to have a right search word. And antimicrobial blue light is one. Then, of course, your microbe in question, and the hygiene standards and so forth. And then the one very important thing is that is this article peer reviewed, and the journal, what is the journal impact factor? Not that important, but the article's peer reviewers is quite an important thing. And that means that the article has went through a review board before it's given or if it's before it's allowed to be published. And how to interpret the scientific article on antimicrobial blue light? Results depend on very many factors. The wavelength that is used, is it 405 only, or something in between, or is it so-called multi-wavelength power source like the Spectral Blue lamps are? Then power of the light source and the intensity of the target. And here you find often in the article, so you find different parameters like watts or milliwatts per square centimeter. So these differ, and they of course then have the effect on the results. The exposure time, seconds, and the energy dose, which is joules per square centimeter. And then one important factor is the distance between light source and the target to be disinfected, of course. Organic load of the target, presence of biofilm, because blue light does not clean, it only kills the bacteria on the surfaces that it's supposed to clean and or disinfect, and the cleaning must be done manually, of course. And if the organic load is very high, so that makes the challenge, or it challenges the blue light very much. Then, of course, the microbes. There are differences between bacteria, antibiotic-resistant bacteria, bacterial spores, viruses, and molds. But let's say the general fact is that only the bacterial spores are most difficult to kill in these, if we are thinking of these organisms. And then some articles that I picked from the 200 plus articles, and they are of course mainly on the food area. So here is an article from the Journal of Food Protection, which is an official journal of International Association of Food Protection, and it's very highly appreciated in this area. This article studies the effect on blue light on Listeria monocytogenes on inert surfaces, stainless steel and polytetrafluoroethylene, easier to say, some kind of a Teflon surface, and combined with chemical sanitizers. And I think this is a very important journal because we need to have some kind of chemical sanitizers, cleaners, disinfectants, and the blue light. Because as I told you, so the blue light does not do the cleaning, it does disinfection. And we have to clean the surfaces before the disinfection. And that is very good news, that blue light enhances the bactericidal effect of these disinfectants. So that's an interesting article, for example. And then one on biofilms. Biofilms is usually, I would say that they are most often multi-species biofilms. So it means that they are composed of many different bacterial species and not only like one bacterial species. In food industry, of course, Listeria is one of the biggest challenges forming the biofilm. And of course, this is very logical, so that the multi-species biofilms are showed higher growth than single species biofilms. That would, if we think of the food safety. And this is a special critical factor if we think of improving the contamination control of the ready-eat foods like sushi and so forth. And does surface color matter with the antimicrobial blue light? I thought this was really a fun article, since first I read this article and they have studied red, blue, black, green and white surfaces and then different treatment times. And then first I thought that, well, is this really relevant? So that does the surface color really matter? But then I learned that very many surfaces that are contact in the food product are blue in food industry. And this is a very good news, since the blue colored coupons that they use as surfaces had the highest decrease of Listeria population after 4 to or 8 hours. So that it must be that the blue light reflects the or the blue surface reflects the blue light best. And then this study is of several pathogens and spoilage bacteria in the food industry. They used cocktails of Listeria, Salmonella, Escherichia, Pseudomonas, Chronobacter, Lactobacillus, and Staphylococcus, and then on the stainless steel coupons, as well as on avocados and cherry tomatoes as dried cells. And the reductions with the 405 nanometer ABL in 2 temperatures, and they had the result at a very high blue light dose used. It's 500 to 1500 joules per square centimeter, which results a several log reduction in most cases from 2 to 8 logarithms. And the Spectral Blue uses very much lower light dose, but usually as we have studied our devices, so they do very good job. And this mostly depends on the fact that this is an artificial bacterial cocktail, and the starting CFU per millimeters are very high, so that you don't actually need, in real life, you never see these 8 logarithm reductions, since the contamination rates usually in real world are something like 10 to the 3, 10 to the 4 mostly on these surfaces to be disinfected. And the summary and the take-home message from this is that there is a high interest in the antimicrobial blue light. There are very many studies already in the last 15 years, and the most, of course, are concentrated on healthcare, food industry, and then maybe like the scientific study of the blue light itself. And the reading of these studies may be quite difficult because of the varying parameters. But if you have any questions and you think that why does this article say that blue light has this and this and this effect, and the other one says that it doesn't have an effect, so please contact us, and we try to interpret the results and the articles in the best way we can. And we always do the 3D simulation to ensure the efficacy in your facilities, so request that service for free.
Thank you, Kirsi, for your nice presentation, and thank you, Bob. Very interesting information for us. So thank you for attending this webinar session today, and let's stay in touch. You can send any questions or request a free 3D planning by writing us an email, info@ledtaylor.com. You can also follow us on LinkedIn for latest news and next events. And feel free to check out our video recordings of past webinars on our website. Thank you again, and see you next time.